Hello everyone. Today's topic which we are going to cover is single phase semiconverter with RLE load and freewheeling diode. Now previously we have covered single phase full converter with RLE load, right? With continuous and discontinuous load current. So today we are going to focus on discontinuous load current mode. So this is what is discontinuous load current mode. So what do you mean by discontinuous load current mode? In case of discontinuous load current mode, your load current goes to zero at an interval of omega t equal to beta, pi plus beta, and etc. Where beta is the extension angle. Now this is my circuit diagram, right? I have a single phase supply. It is connected to a symmetric semiconverter configuration. So T1 and T2 are my SCRs. D1 and D2 are my uncontrolled diodes, rectifier diodes, and DFWD is my freewheeling diode, right? And we have a RLE load over here at the output. Now, if I collectively see if my output is actually equal to I into R, that is the current into resistance, then L di by dt, and then plus E. So if any of the SCR and a combination of a diode is on, my output will be following the input. So in this case, Vm sin omega t will be output. So Vm sin omega t minus E will be equal to IR plus L di by dt. So this is the equation which we have, which will be govern the working of the circuit. Now, this freewheeling current will flow, which is I freewheeling diode current will flow only when this diode is on. Alright. So let us start with the working of this. First of all, in case of discontinuous load current conduction, your comparison between V in and E is essential to decide the finding of the SCR. Right. So in case of continuous current, as we know, the I out never reaches to zero. But in case of discontinuous mode, this really happens. Alright. So there is one incomplete thing which I have to cover. The I out starts from zero. Yeah. So let us begin with the working of the circuit. Yes. So let's go to the waveforms now. Yeah, this is V in, right? The blue color one is my V in, and the orange color one is my E. This is a DC voltage E. So correspondingly, if I extend it down, this is theta 1, this is theta 2, and this is pi, 2 pi, and 3 pi. Now I apply my gate trigger at alpha, pi plus alpha. At alpha, I apply the gate trigger for transist, I mean for SCR T1, and from 2 at 2 pi plus alpha also I applied for transistor T1, that is IG1. And similarly at pi plus alpha and 3 pi plus alpha I applied for SCR T2. So once we get the gate trigger and when the SCR is forward bias, only then it will conduct, right? So from 0, from omega t equal to 0 till theta 1. As you can see from the waveform, the V in is lesser than E, right? So what is the V in doing, E doing in the picture? The E is making the job difficult for the SCRs to turn on, right? Priorly it has to overcome V in minus E voltage. Alright, here it is. Then it will turn on. That means this V in value has to be greater than E for that particular SCR to turn on. So between the positive, in the positive half cycle, which devices will turn on, which are eligible to turn on? T1 will turn on and D1 will turn on in the positive half cycle, and in the negative half cycle, which are possibly turning on, will turn on T2 and D2. But when the thyristors will turn on depends upon us. It depends upon the firing angle, right? So let's start analysis. So from 0 to theta 1, what happens really? So from 0 to theta 1, your V in is less than E. So your SCR T1 will be in the reverse blocking mode. Your yeah, your SCR T1 will be off. Only diode D1 will be on, right? Because we are in the positive half cycle. So eventually we require a pair for that output to follow the input, source voltage. But in this case, T2 and D2 are off only in a positive half cycle. So no question of them being on. D1 is on, T1 is off. So my output will be actually zero because the current flowing through it will be zero. Now, uh, This is actually written over here from theta 1 to alpha, but what we are discussing from 0 to theta 1. So d 0 to theta 1, your d1 will be forward bias, t1 will be off, so your iot will be 0 because no current flows, to vr is 0. Now L behaves as a short circuit because the VL across it, the voltage across it is 0. Why the voltage across it is 0? Because di by dt, the current is 0, right? And if you can see carefully at the output, you have just V. E voltage, that is your RLE. E can be a battery or a back EMF of a DC motor. So here the output is actually equal to E, right? Here it is. From 0 to theta 1, the output is not 0, it is equal to E, even though the current is 0. I out will be 0, your I in also will be 0, and your forward, the freewheeling diode current also will be 0 because that is not active at all. So this is what happens. Now the same behavior will continue from theta 1 to alpha. Now what is the difference from theta 1 to alpha? Your SCR T1 is in the forward blocking mode, right? Earlier from 0 to theta 1 it was in the reverse blocking mode. Now from theta 1 to alpha it is eligible to turn on, but it is not yet turning on. The same situation will arise. Your I out and I in will be equal to 0. Your V out is still equal to E. So here it is. Your I out is equal to 0, your V out is still equal to E, right? Now we apply the gate trigger, alpha arrives, right? So as soon as you apply the gate trigger, so we are discussing the behavior between alpha and pi. Alpha and theta 2, let's say. So from alpha to theta 2, your SCR T1 were triggered, right? They are triggered at omega t equal to alpha. So they turn on, so your I out current will start to build up, right? At the same time, the inductor will start to store the energy, right? In the positive half cycle, if I out is building up and it's flowing through R, L, and E, the current flowing to the inductor, it will store that energy, right, in the form of magnetic field. So now what happens? The I out starts building up till theta 2, right? So after theta 2 again, your V in is becoming less than E. But what is happening is, now let's see the current part when when the I out is starting to build up. So how will the current flow? It will flow from A transistor T1, SCR T1, then point C, RLE load, point D, D1, and back to B. So this is will be the current part during the positive half cycle when the T1 is triggered on. All right, and yeah, in this case, your output voltage, your source voltage will be connected to the output voltage via the devices T1 and D1. All right. So this is what happens between alpha and theta 2. So what happens after theta 2? The V in is becoming less than E. So normally what should happen? The T1 should go to reverse blocking mode. But it does not happen because of the inductor stored energy. Your T1 continue to conduct till pi, right? Actually T1 continues to conduct till beta, right? We have discussed about RL load before, why there is a extra conduction till beta because of the inductor stored energy, and this happens only in the uh, you know discontinuous mode of operation, discontinuous load current. In this case, your I in and I out will be same. So from 0 to theta 2 or theta 2 to pi, your current gets built up. And now after pi, it starts reducing because after pi, your negative half cycle appears. So after pi, your polarity across the V changes and you got enter into the negative half cycle. So here it is. We are entering the negative half cycle after pi. All right. So then what happens? The I out keeps on decreasing and it will be going to 0 at beta, right? A beta is the extensile angle. Here is the value of beta. Here it is. Okay. So till beta, I mean, uh, yeah. So, but in between, something else also happens, right? So let's consider the working between alpha and pi. So alpha and pi, your I out is increasing and then slightly decreasing after pi value, but we are concentrating on the behavior till pi. So your V out will continue to follow the input, voltages. That will be your output will be following the input nature, right? Then what happens? So during the period alpha and pi, your T1 and D1 will conduct. Then what happens? Let's consider that. Okay. So from pi to beta, your V enter the negative half cycle. So at omega t equal to pi, this is the situation. T1 and D1 are on. and we enter a negative half cycle, so the polarity across V in will change. All right. Now this positive will come over here, right? And it will, it is actually coming over here, and this negative is coming over here. All right. And this negative is over here, and this positive goes over here. That means we are forward biasing the freewheeling diode. So what happens at as soon as omega t crosses pi, your freewheeling diode turns on, and when the freewheeling diode turns on, your freewheeling current freewheeling diode current flows into the circuit, and output voltage instantly becomes zero. In becomes zero, because when the current flows to the freewheeling diode, your input source is completely isolated in this period, right? So from this happens from pi to alpha, right? Your freewheeling diode is on. So let's see, from pi to alpha, your output voltage is becomes zero, right? Your freewheeling diode is on, your in current is zero, and your I out will be zero at omega t equal to beta, right? From pi to beta, it will continue to decrease. I out will continue to decrease, and at omega t equal to beta, it will be zero, right? That's how the working of RL load is. Now, after that, what happens from beta to pi plus alpha? From beta to pi plus alpha, the same situation arises as we have arise from 0 to alpha. So in that case, your T2 transit, T2 beyond in a negative half cycle, T2 is eligible to conduct. But in this case, until you get a next trigger pulse, your T2 remains off. So now what happens? Let me show it to you. Now you enter a negative half cycle. So your T2 and D2 are eligible to conduct, but only D2 conducts, right? Because T1 has not received a gate pulse. So what happens? Your output current is zero, and output voltage will be equal to E as explained in the previous sequence, right? So from beta to pi plus alpha, your T2 is in a forward blocking mode but off, and D2 is on. So your I out will be 0 and V out will be equal to E as drawn over here. Here it is, from beta to pi plus alpha. Now in this period, your ion current will be 0, and you can see from pi to beta, your forward, freewheeling diode current flows. So if I combine I in and freewheeling diode current, it will be I out only, right? This you can easily, prove it over here. Here we have incoming current as forward, freewheeling diode current plus the input source current is equal to outgoing current, which is I out. So I out is actually I in plus IFWD. That's what we have written over here. Here it is, right? Now, till pi plus alpha, what happens? Now we are checking the working from pi plus alpha to 2 pi. So pi plus alpha, your T2 SCR is triggered on, and D2 is already on. So your output voltage will follow negative of input. So let me show it over here. Here it is. So this is how the connections will be. Your input source will be connected to the load but with opposite polarity via D2 and T2 devices connected to the RL load, right? So here in this case, since the direction of the input source current has changed, but the direction of the output load current has not changed. Why? Because of the unidirectional nature of current flow through the diode as well as the SCR. It will not allow the current to flow in the opposite direction, right? So the current flows from B to T2, point C, RLE load D, D2 and back to A. So I out will be equal to minus V in, I have already explained that, and V out will be equal to minus of V in. That will be source will be connected to the load but with a reverse polarity through D2 and T2 and D2. Now again, during this period, the inductor will store the energy, and it will current will become zero at pi plus beta, and this way the sequence will repeat, and you will get a periodic waveform, but it's not at all sinusoidal. As you can see, it will contain harmonics in the picture. So this is how the working will be, and during this period, as I've told you all, your I out will be equal to minus of, here it is, I out will be equal to minus of I in, and here it is displayed over here, right? And V out will be equal to minus of V in. So V in, this is this dotted line is for V in, and this dotted line is for minus V in. So that's why we get in the positive half cycle. So as you can see, in a semi converter, output average voltage is always positive, And with the freewheeling diode, your from pi to beta, from 2 pi to pi plus beta, these are all freewheeling period, right? Or freewheeling conduction, where only the freewheeling diode is turning on and none of the, and during the freewheeling period what happens really? So whatever the energy stored inside the inductor, that is being released via this short circuit part, which has been provided by freewheeling diode once it turns on, and that will make V out equal to 0. All right. So this is how the sequence of event will unfold, and your cycle will repeat itself. Now, in summary, from the voltage and current waveforms, conduction periods are from alpha to pi, pi plus alpha to 2 pi, wherein your from alpha to pi, your T1 and D1 conducts, SCR T1 and diode D1 will conduct, and output voltage will be equal to V in. From pi plus alpha to 2 pi, T2 and D2 will conduct, and output voltage will be equal to minus V in, and so on it will continue. Freewheeling periods are pi to beta, where your freewheeling diode will conduct and output will be equal to 0. From 2 pi to pi plus beta, your freewheeling diode will conduct and output voltage will be equal to 0, and so on. The ideal periods are when none of the devices are conducting and the output is equal to E, since the output load current is 0, is between beta and pi plus alpha, when none of the device conducts, and pi plus beta to 2 pi plus alpha. Please note that the load current with, I mean, the load performance with the discontinuous load current will deteriorate. Okay, the load performance will deteriorate with the, uh, you know, this current mode of operation. So, such a load current which is discontinuous is not used practically. We go for a continuous load current, cases with RLE load or RL load with semi converter. All right. So yeah, so that will be the working of this single phase semi converter with RLE load and freewheeling diode. So that will be all for the session. Next time we'll start with a new topic. Until then, have a good day and thank you.